Hello everyone, welcome to our second lecture of Electronic Devices and Circuits 2 class. This is a continuation of our first lecture on op-amp. In our first lecture, we discussed about the basic device structure, the pin configuration of the op-amp, and the different features, the characteristics features, properties, the equivalent circuit, the circuit symbol. So in general, our focus was on the op-amp as a device, and now in the second lecture our focus will be shifted from device to circuit. So here we'll discuss how we can use the op-amp in a circuit and how to analyze those circuits. So basically we'll learn the circuit application of the op-amp and how to analyze op-amp circuits. So let's start. So op-amp in open loop connection. So op-amp basically we can use in circuit in two different ways. One we call it open loop connection, the other is the closed loop connection that we have already mentioned in our first lecture. Now we'll see in detail. So in the second lecture our focus will be on open loop connection. The closed loop we'll discuss in our third lecture. So basically we'll first see how we can connect the op-amp in open loop connection and how to analyze those circuits and what are the applications. So this is an example of open loop connection for op-amp. In open loop connection, what we see is that the input voltages we connect directly to the input of the amplifier, and we take the output from the output terminal, and that is what is known as the open loop connection. Now in open loop connection we can have different combinations. Here both the inputs are DC voltages. We can have a combination of this. Here both the inputs are AC voltages. So and we can have different combinations. So in this case we have a mixture. So input 1 is DC and the input 2 is an AC voltage. So we have a combination of AC and DC. Now here in this diagram you can see that input 1 is DC but input 2 is grounded, right? So we can also have something like this. So we apply input to one of the terminal and the other one, while the other one is grounded. This one, it shows that we have applied an AC signal to our non-inverting input terminal, and the inverting input terminal is grounded. So we can have different combinations in open loop connection. These are some of the examples how the input voltages can be applied in open loop connection. So what are the features in open loop connection? First we'll just describe the features and then we'll prove those features in our subsequent slides. So what are the features in open loop connection? How does the circuit behave in open loop connection? So op-amp in open loop connection can have only two outputs, either positive maximum or negative maximum voltages. So this is the main feature of the op-amp in open loop connection. It can have only two outputs and no other outputs are allowed. Like that digital circuit. Digital circuit, they are designed to give you only two outputs. You get either high or low. Similarly, op-amp in open loop connection, you can have only two outputs. Either you can have a positive maximum voltage or you can have a negative maximum voltage. You cannot have any other output, right? Nothing in between or nothing more or less. So it basically, op-amp in open loop connection behaves like a digital circuit with only two outputs, either high, the maximum, the positive maximum can be considered as high, while the negative maximum you can consider as a low output. So op-amp in open loop connection cannot be used as an amplifier, doesn't work as an amplifier, because amplifier, the basic nature of the amplifier is that output, the input is amplified, right, and appears at the output. So the higher the input, the higher the output, the lower the input, the lower the output. So it's just proportional, output is just proportional to input. But in this case, op-amp in open loop connection, you don't have that that characteristics, that feature. So output, you have just two outputs, and either high or low, that's fixed, and it does not change when you change the input. It changes, but if it change, then it will change to either high or low. It doesn't depend on the absolute magnitude. It does not depend on the absolute magnitude of the input voltages, rather on their relative magnitude. So the op-amp in open loop connection, we cannot use it as an amplifier, but we have some other application. As we have mentioned, we can use this as a switch, as the high, when the output is high, that can use to turn on something. When it goes low, you can use that to turn off something. So that is one application to for the op-amp in open loop connection as a switch. The other applications are comparator circuit. There are two outputs, two inputs, and output will depend on the relative magnitude of the input voltages. You can know which one is high or which one low, or also can be used as a voltage detector. So when the output changes from low to high or high to low, so you know the input has crossed certain threshold voltage. So that's how we can also use the op-amp in open loop, a voltage level detector. So now we'll go into the circuit operation. So how does it work in open loop connection, and how we can analyze the circuit. Okay, so this is our basic circuit op-amp in open loop connection, and the input voltages V1, V2 can be either AC or DC, but we don't care about that right now. And just two voltages, they can have any value. Now the output is given by this expression. The AOL stands for the open loop gain of the op-amp, because this is open loop connection of the op-amp, and the gain of the op-amp we denote as the open loop gain. Now the output is the amplified form of the input. Now what will be the input in this case, because we have two input voltages V1, V2, but interestingly the op-amp, it doesn't amplify either V1 or V2, it amplifies the difference between these two voltages. So you take V2 minus V1, that's difference voltage, and then multiplied by AOL, the gain, open loop gain of the amplifier, that should be the output. Now imagine for the ideal op-amp, the open loop gain is infinite, that we discussed in our lecture 1, the features. The ideal op-amp feature is infinite open loop gain. Practical op-amp, it's not infinite, it's finite, but it's still very high, like 10 to the 5 or 10 to the 6. So what happens if we have an infinite open loop gain, right? So this is how we can express the difference. V2 minus V1 is also denoted as VID, that's a differential input voltage, that's the difference between these two, that also mentioned in our previous classes. Now when you multiply something by infinity, the output should be, the value should be infinite, right? But that is not practically possible. You cannot have an infinite output infinite output from a device, or you cannot generate an infinite voltage. That is not possible. So what we can expect at the output? Op-amp is a tiny device, of course. Forget about infinity, you cannot even get 100 volt. 100 volt is too high, it will just, if you apply 100 volt to an op-amp, it will just melt. Maximum voltage that is applied to the op-amp are the supply voltages, and the maximum is about 20 volt. Usually it varies 10, 15, different op-amp will have different specifications, but usually the maximum voltage here would be about 20 volt. So the output, what output you can get? So practically you will get the maximum possible voltage that op-amp can provide. You cannot get infinity, but op-amp will produce an output voltage that will be the maximum limit for the op-amp, and that maximum limit will be determined by these supply voltages. It can be either positive or it can be negative. Now, how do we know whether it will be positive maximum or it will be negative maximum? So that will depend on this relative value of V2 and V1. If V2 is greater than V1, then VID will be positive, and you can expect to have a positive maximum voltage. That is called V saturation voltage. So saturation means that you can change the input, you can increase the input VID, but your output will not change. It has saturated, so it's called saturation voltage. So if VID is positive, that means V2 is greater than V1, so you get maximum positive voltage, and that is called the positive saturation voltage. Now if V2 is less than V1, then VID will be negative, and you can expect a negative maximum voltage, that is called negative saturation voltage, and is denoted as V sat with the minus sign. So that will be the output, and you see from our this discussion, we can have output either positive maximum or negative maximum. That depends on the relative magnitude of V2 and V1. If V2 is greater than V1, you get the maximum positive voltage, positive saturation voltage, and if V2 is less than V1, you get negative maximum voltage or negative saturation voltage. That is why op-amp in open loop condition can have only two outputs. It cannot have any output in between. It can have either positive saturation or negative saturation depending on the relative magnitude. As long as V2 is greater than V1, output remains fixed at positive saturation. We can increase V2, but it will not change. And similarly, as long as V2 is less than V1, output remains V saturation minus. It remains fixed at this magnitude. It does not change as long as V2 remains less than V1. So now, what are these saturation voltage? How do we determine the saturation voltage? One thing is for sure that these saturation voltages, their maximum value depends on the supply voltages. V saturation, positive saturation voltage will depend on the positive supply voltage. The negative saturation voltage will depend on the negative supply voltage, but it will be slightly less than that because of the internal drop in the op-amp. So positive saturation voltage is given as V plus the positive supply voltage minus the del V. Del V is a small voltage drop inside the op-amp. The negative saturation voltage is V minus plus del V. You see that in this case we are adding up instead of subtracting, because V minus is negative. So if you do minus, it will be more negative. We cannot get more negative than what you apply. So you can only get less negative, less positive and less negative. So V minus plus del V, and del V is, we call the internal voltage drop. We are applying the voltage at this terminal. Supply voltage will be pin 4 and pin 7, and you are taking output from the another pin, that is pin 6. Now you cannot have exactly same voltage because there are circuitry inside the op-amp, and there will be some voltage drop in those circuit components, and the voltage here will be slightly less than the voltage that we apply at these terminals. So that is called the internal voltage drop. So that is the operation mechanism of the op-amp in open loop connection, and from that we understand that in open loop connection we can have two output voltages, positive saturation, the positive maximum, and the negative maximum, which are called the saturation voltages. Okay, so to summarize, op-amp in open loop connection, we can have only two outputs, the saturation voltages. So if V2 greater than V1 is positive saturation, V2 less than V1 negative saturation, behaves like a digital circuit, so either high or low. V saturation is we can consider to be high, V saturation minus can be considered to be low. And so in open loop connection it cannot be used as an amplifier because the output remains fixed at just two voltages. Yeah, so that's all about our open loop connection, the behavior and the features, the op-amp in open loop connection. Okay, so now we have a small exercise to test your level of understanding, how much you have understood about the operation of the op-amp in open loop connection. So here we show the diagram, the op-amp in open loop connection, and these values are given for the supply voltages, V plus 12 volt, V minus 12. The del V is the internal drop in the circuit is 2 volt. Now we have a different combination of the input voltages, V1 0, V2 2, V1 0, V2 minus 2, V2 2, and V1 2 and V2 0. So what will be the magnitude of the output voltage for these different input voltage combinations, right? So first what we need to do, we need to see if V1 is greater than V2, or if it is, or in other way we have to see if V2 is greater than V1 or it's less than V1. If V2 is greater than V1, then you will get positive saturation, and if V2 less than V1, you get negative saturation. So it is obvious that this one here, V2 greater than V1, so you get positive saturation. This one less than V1, you get negative saturation, and this one also, V2 less than V1, you get negative saturation. So what we need to do, we need to determine the saturation voltages, and just we can fill up the table then. So saturation voltages, we have been given this magnitude of V plus the supply voltages and the internal voltage drop. So saturation voltages, V sat plus is the supply voltage minus del V, that is 12, del V is 2 minus 2, we get 10. The negative saturation is V minus plus del V, so V minus is minus 12, and that plus 2, we get minus 10. So this is how we determine the saturation voltages, plus 10 and minus 10. Now you can just easily fill up the table. Number 1, V1 is 0, V2 is 2, V2 is greater than V1, so you get will get positive saturation. At the output it will be 10 volt. Second case, V2 minus 2, so V2 is less than V1, V2 less than V1, so output will be negative saturation, so it will be minus 10. Third one, also V2 less than V1, so in this case also output will be negative saturation, minus 10.